In this video, let's learn how to test for primality. Here is a problem statement. Given a natural number n, determine if the number is prime or not. What is a prime number? Well, a prime number is a natural number greater than 1 that is not a product of two smaller natural numbers. For example, is prime of 5 is true since it can only be expressed as 1 into 5 or 5 into 1. Is prime of 4, on the other hand, returns false since it can be expressed as 2 times 2. If you've understood the problem statement, please pause the video and try to solve the problem. Alright, let's now solve the problem together. In VS Code, in JS file, let's begin by defining the function signature. Function is prime, parentheses and curly braces. This will have one parameter n, which represents the natural number for which we need to run the primary test. For example, calling the function with n equal to 1, 5 and 4 should return false, true and false respectively. Now, what we do know about the prime numbers? We know it is a natural number greater than 1. So, let's begin by adding an if condition. If n is less than 2, return false. So if you call the function passing in 1, 0 or any negative number, we return false right away. Next, if n is greater than 1, we need to check if it is divisible by any smaller numbers. For that, we use a for loop that starts at 2 since every number is divisible by 1, and we compare till n. So for that I is equal to 2, I less than n, I plus plus. The condition is less than n, and not less than or equal to n, since n is always divisible by itself. Now, in each iteration, we check if the number is divisible by I. So if n modulus I is equal to 0. And if this is the case, n is not a prime number, we return false. However, if the loop has completed and no number could divide n, it is a prime and we return true. That is pretty much the code needed to perform a primality test on a number. Let's verify by running the code. We see the three values corresponding to each function call: false, true and false. For 1, 5 and 4 respectively. Our code works as expected. That I would like to do now is take a pen and paper and trace the function execution for n is equal to 5. That will give you a more clear understanding of the code we have written. Alright, next it's time to determine the big O of our isPrime function. Pause for a minute and determine the big O. Here is a cheat sheet which can be used as a guide. Pause now or let's estimate the big O together. Our function contains one for loop from our cheat sheet, it is pretty evident that big O is linear time complexity. So big O is equal to O of n, as the value of n increases. The number of times line 6 executed also increases. Now what we have here is a good first solution. If you're a math expert, you probably know a slightly more optimal solution. Integers larger than the square root do not need to be checked, because whenever n is equal to a times b, one of the two factors a and b is less than or equal to the square root of n. Of course, we are no math experts here, so I want to take this statement for granted. However, let's us go through two simple examples to validate the statement. Take n as equal to 24, a equals 4 and b equals 6. The square root of 24 is 4.89. 4 is less than 4.89. A is less than the square root of n. Take n is equal to 35. A equals 5 and b equals 7. The square root of 35 is 5.91. 5 is less than 5.91. So a is less than the square root of n. As you can see, if a number is composite that is not prime, you will find a divisor at less than or equal to the square root of that number. This implies we can change the comparison in our for loop to I less than or equal to math dot square root of n. Rerun the code and we still see the same output. The solution, however, is more optimal. Let's now determine the time complexity. If n is equal to 100, we check till n is equal to 10. If n is equal to 10,000, we check till 100. So, as the size of n increases a number of times, the for loop statement executes increases but not in the same proportion. This optimize function doesn't have O of n time complexity, but instead has O of square root of n. Alright, that concludes our primality test algorithm. For our last math algorithm, let's learn about the power of 2 algorithm. Thank you for watching, make sure to subscribe to the channel and I'll see you in the next video.